What's going on, guys? In this video we are going to see an example of diode circuit. Here we have a diode circuit and the question here is asking identify which diode is on and which diode is off. Now there are two different approach we can do. We can do short circuit method or we can use open circuit method. And short circuit method is basically we assume this diode is on and in forward bias and we short circuit this one, right? And short circuit, and then we calculate the current. If the current is positive, then this diode is on. Like we always assume the current direction from anode to cathode. Anode is this side and cathode is this line side, is the cathode side. So whenever we have a diode like this, we assume this direction, anode to cathode. And for this one it's going to be same thing. And if we calculate this current, and if the current is positive, it means our assumption is correct, the diode is on, it's in forward bias. If it's not, if we get a negative value for current, it means the diode is off, or it's in reverse bias and our assumption is wrong, and we replace that one with open circuit. And that's what we have to do. Now let's look at this one. First we have to calculate the current, but in order to do that, first we have to do the short circuit method. I can replace this circuit with the short circuit. Okay, in order to do the short circuit method, we have to replace this circuit with the short circuit. If we replace this one with the short circuit, it's going to look like this. We are going to have a circuit like this, and here, okay, let's call this voltage V. So here we can redraw this one as like this. Okay, this voltage is V, and then here we have this one, and this is 10 ohm resistance, and this is connected to the ground. Okay, this voltage is 8 voltage and this is 3 voltage and this is V, and this resistance is 1k and this is also 1k. And since the diode is like, we always assume the current's direction from anode to cathode. This is the anode side, this is the cathode side, so we assume the current is in this direction. Let's call this one I1, and let's call this one I2, and let's call this one I3. Okay, so here we can apply KCL at this node. Whatever the current entering this node is equal to exiting the node, and if we do that, this is going to become I1 plus I2 should be equal to I3. Okay, I1 is what, 8 minus V divided by the resistance in between, that's 1k. So 8 minus V divided by 1k, and then I2 is going to be 3 minus V divided by 1k. 3 minus V divided by 1k, that is equivalent to V minus 0 divided by 10. This is 10k, right? 10k. So this is gonna be V minus 0 divided by 10k. Here we can cancel all the k's. This k cancels. Therefore we are going to have 80 minus 10V plus 30 minus 10V is equal to V. Okay, so this is going to be negative 20V. If we bring this negative 20V to this side, this is going to add up with this one, so we are going to have 21V, that's equal to 110. Therefore V is going to be 110 divided by 21, and if you calculate that value, that's going to be 5.24. so this is going to be our voltage right here. Now here we found out the voltage here. Now we have to see whether we are getting the current in positive. If we get the current positive, it means our assumption is correct. This is in forward bias and this is an open circuit. Now let's look at the I1. I1 is going to be 8, and we found out this voltage. This is 5.24 divided by 1k. This is a positive current, right? Because we are getting 3. It's going to be 3.5. If you subtract 5.24, this is going to be 2.76, right? 76 milliampere. This is a positive current. It means this is correct. This is open circuit, like this is a short circuit, and this is in forward bias. So we can say D1 is in forward bias. D1 is in forward bias. Okay, and on. If it's forward bias, it's on. Now let's look at I2. I2 is 3 minus 5.24. 3 minus 5.24 divided by 1K. This is a negative current, right? This is going to be negative 2.24 milliampere. So this is not correct, because if it's negative, it means this is a reverse bias, this is off. Reverse D2 is reverse bias and it's off. It means this is not a short circuit, this is open. So this is wrong. And that's how we do this kind of problems. I hope this helps. Thanks for watching.